Okay. System dynamic. Bunu şey yapma. Kendi aranızda konuşmayın arkadaşlar. Konuşacaksanız dışarı çıkın. Olur mu? Baksanıza. İsterseniz dışarı çıkabilirsiniz. Okay. Today we are going to start to the dynamic response and Laplace transform. This is our topic. Okay? Mainly the purpose of this topic are given by analyzing equations in time domain. Okay? Firstly, we need to talk about it in order to understand the time response and its characteristics. Okay? And after that, this time response is divided into the three parts, actually four parts: the steady state, transient, forced, and free. Okay? After that, we will introduce the time constant and oscillation frequency, or this is called to natural frequency. And as we lost the energy in the system, we need to introduce the damping ratio. Okay? Kardeşim şunu biraz daha çekebilir misin ya şeyde? Heh, çok sağ ol. And in order to describe the whole this equation, the time response, natural frequency, or the damping ratio in the Laplace domain, we will introduce the transfer function and impulse response. Okay? These are topics of this lesson today. And then we are going to start with the differential equations. What's the meaning of the differential? Can anyone say that? For example, what's your name? Daye. Berlin. Derya. Okay, no, I'm sorry. What's the meaning of the differential? Yes. Differential. But what's the meaning of the differential in the math? For example, what's the meaning of the differential? Can anyone say that? Yes. Yes. It depends on some other variable. But in terms of in terms of the D operator, or we have the sum operator, it's going to the zero value, which we call it the derivative, right? And so this derivative can be represented by the some functions, the variables, which we call it the differential, right? Just like in the car, differential transmit the one part to the another, right? And so this is used to the math equation, or the equations into the sum equation into the another one by using the derivative operator. Okay? And so firstly, we need to talk about the ordinary differential equations. In short, ODE. Okay? And so, what's the meaning of this? the meaning of the what? Combination of derivatives depending on the what? On some variables, right? This is the important part. Variables, derivative, and depending, which we call it the what? The ordinary differential equation. For example, if I write the x dot dx dt or z dot dot dz square dt square, and so we can say that this is the differential equation, ordinary differential equation, okay? Or we can write that 3 dot x dot dot plus 7x dot plus 2 times t square x is equal to what? The cos t, okay? And so this is the R system. And so what is the system parameters in here? We have the x variable dependent of the what? Dependent of the, what's your name? Go. What's your name? Beza. Beza. It depends on the what in this equation? The x is dependent of or on two derivative, but which parameter is affected to write this differential equation? It's a time, right? Okay. And so we have the time derivative. And so this is the ordinary differential equation based on the what? The time definition, right? And so what is the system or the system parameters in here? Can anyone say that? We have the formulation in here just like this one. X dot, that's the second derivative time operator on this x, right? But we have the sum coefficients in here, 3, 7, 2 t square. And so it shows to what how we can handle or how we can relate these two x dot dot x dot to each other, right? And so the system parameters in here, 3, 7, 2 times t square form, okay? And so this is our system. We can generate the time history or the time response of the x based on the what? The time, okay? And so if we equalize this equation into the what? Into the right hand side, which we call it to the what? To the input, because we don't have any x value in here, right? This is called input, this is called the system. So the x dependent variable and xt is the what? The time response of this equation. And so in order to solve this equation, we need to utilize to what? Some other parameters, which we call the initial condition, right? Because we have the differential operator in x dot dot, which means that we need to what? The x dot initial value. If we are using the first order equation, Daria, and so we need to know to what in order to solve this equation? To what? We need to know the x0 value in here. And so in order to solve the first order equation, we need to know the initial condition of the what? The x, right? Because we need to know it at the first part or the beginning time value relates to what? To the x, right? Otherwise we cannot solve it. So this is our the basic definition about what the ordinary differential equations. And so we need to talk about the ODEs, just like this one. ODEs are linear or non-linear. What's the difference? Can anyone say that? What is the difference between the linear and non-linear, guys? And what's your name? No, you. Hajar. Hajar, what's the difference between the linear and non-linear? Yes. Yes. And non-linear, if we shift the time parameter, for example, if we have the t is equal to the 0, and so x is equal to the 2, okay? This is our condition. And after that, if we shift the time, for example, to 5, and so if we shift x without any operation, and then we can say it's linear, otherwise non-linear, okay? For example, we have the x dot plus 3x equals 5 plus t square. It's linear or not? This is first order equation. First order. Because we have the one dot operator. It's linear or not? Arkadaşlar bunu bilmeniz lazım. Yani üzülüyorum şu an gerçekten. I'm sorry about that. Why? Okay, it's linear because we don't have any shifting operator that causes to what the system non-linear. For example, if we iterate, the x value is a dependent variable in here, and the t is the base variable, and so t square is the input of our system, but the x is not changed with the square form or the square root form in here, and so we can scale this system on the time, okay? And so this is linear. And so in order to understand the nonlinear system, we can write the 2 dot x dot dot plus 5 x dot plus 1 times x over 3, which is equal to the 5 t square. This is linear. But this is nonlinear because the x have the non-constant parameter with the multiplication term x over 3, right? If we have the x value, and so we can say that this is linear, right? And so this equation is the second order one. Second order. And so x dot dot plus 4x x dot plus 20x is equal to the t. It is linear or not? Why? Yes, x and x dot is multiplied within each other, and so this creates the time shifting cannot be done on this property, okay? This is nonlinear. Nonlinear, okay? And so, what about this one? X dot dot plus 4t x is equal to the 5. It is linear or nonlinear? Linear. Why? Yes, but the t may be changed in time, okay? And so this is linear, but variable coefficient is given in here with the base of the t, and so this is changed in time, but the change is dependent on the time, and so this is the variable coefficient linear equation in the second order form, okay? Okay, so we will continue with the what? With the two variables. The x1 dot plus 2x1 minus 1x2 is equal to the 5, and also x dot plus 4 times x1 plus 4x2, which is equal to the 0. This is linear or not? This is linear or not? Yes. Why? Yes. Yes, that's correct. And so we can couple the what? The x1t, x2t in here, but we don't have any effect on the what? On the x1 and x2 in the what? In the nonlinear form. For example, if I choose to write the what? The x1 dot x2. This is linear or not? Nonlinear. Why? Yes. This is simple as it is right now. Okay? Do you understand what is the linear or nonlinear right now? Can anyone say the what this linear or nonlinear with this basic definition? Could you say, or for example, if I give your system and then you can decide the linear or not right now, right? Huh? Okay, thank you. So, this is the basic definition of the ordinary differential equation in terms of the what? The order, first order, second order, and linear and nonlinear, or the constant coefficient and the variable coefficients. These are important, okay? Especially for the system dynamics, because we will transfer, or we will define what the transfer function based on the Laplace transformation, which is only utilized in the what? In the linear domain, not the nonlinear one. Or we will write the what? The state space representation of the system dynamic models, which is only current for the what? For linear systems, not the nonlinear one, okay? So, how can we solve this equation? 2.1. Okay, the solution method. We can use the direct integration. For example, if we have any system just like this one, dx divided by dt ft, okay, and so we can split the dx and dt in here just like this one. Dx is equal to the ft dt, and so we can take an integration in here. X t0 xt is equal to what? The dx, and integral ft dt with the what? T0 and t. And so our final form is equal to what? The xt is equal to the xt0 plus integral ft dt. T0 t, right? This is so simple. You can easily analyze and calculate this formulation right now, okay? And so, for example, we can write the equation form just like this one. For example, the ut, this is the input signal, is the t, okay? And so we can assign this value in here, and then the xt can be initialized with what? The xt0 plus t0 t, and so dt. And so which term should be written on this area? We should put the what? The ut into this one, and so we should give to what in here? Which equation should be given in here? Can anyone say that? Hajar? The t. dx dt is equal to the t. Right? Because the ut is the input signal. Okay? And so we can calculate what? The xt0 plus t0 to t. And so what's the integration values of the t in here? Huh? What's the integration value? Square divided by 2, right? And so we can write that the x t0 plus t squared divided by 2 t0 squared divided by 2, right? These are the solution for this system. Okay, this is so simple, but we should utilize another methods in here, the separation of variables. What's the meaning of the separation of variables? Have you heard of these things in any lesson? Separation of variables. Okay, if you don't have anything about this, and so we can write that, suppose that we have x dot is equal to the gt times fx, and then we can write that this is the dx, right? dx divided by dt, dx dt and gt times fx, right? And so the separation of variables can be made or can be done by using what? The x is the left hand side, t on the right hand side, right? And so what's your name? Yes? No, you. Yes? Yes, you? Batuan. Okay, Batuan. Can you tell me how we can organize this equation in here? The x should be what at the left hand side, t on the right hand side. Just tell me. I can write it. Yes, but we need to separate the variables at the left hand side and the right hand side. Okay, and so the x should be what? Should be on the left hand side. And so voila, we have the fx value, and so this fx must be what? To carry it to the what? To the left hand side, right? That's so simple. And so we can write it, this equation, dx times fx, but we need to take the what? 1 divided by fx should be given in here. Why? Why? Thank you. And so the gt is the what? Is given, remains same in here, but this dt should be carried to the what? To the right hand side. Okay? So this is called the separation of variables, guys. We separate the x and t value, and so we can now take an integration for this value, right? Beza, right? Okay. So these are the general formulation for the separation of variables here, and then the example can be given just like this one. The example of solve the what? The x dot is equal to the what? The minus 2x plus 5. Okay, how can we use or solve this equation? Somebody help me, please, I'm begging you. Who is this lucky, guys or girls? Rumeysa, please guide me, help me. Yes, yes, yes, equals, you can say in Turkish, you are free. Yes. Okay. And so, what now? We need to separate the variables, right? Now, yes, dx divided by minus 2x plus 5 equals to dt, right? That's all. And so this is the equation. And so we can take an integration right now because the dx and dt are separated, right? And so we can take the integral operator, or we can use the integral operator right now, okay? And so the integration or the integral rule gives us the 1 divided by minus 2x plus 5 dx is equal to the dt. And so we can assign this to u, and so u is minus 2x plus 5 and du is equal to the minus 2 dx, right? We can convert to this du, or we can use this syntax. And so the dx must be equal to the du minus 2, see? And we can write this integration like this one. 1 divided by u times du divided by minus 2 is equal to the 1 dt, right? And so this is a famous integration which is equals to the what? ln, right? Log, okay? And so we can write the solution is the minus divided by 1 divided by minus 2. It's going to the head, and so ln u value is equal to the t plus some constant value, right? This is the solution of the r integration, okay? Yes, we need to rewrite this u value right now. And so we can write again this value. This is the minus 1 divided times ln u, which is equal to t plus c, right? And so we can write this equation with the ln minus 2x plus 5, right? And so minus 2t 2c, right? Because this term is is carried to the right hand side, okay? And after that we can take the exponential term of this equation right now, like this one, the minus 2x plus 5, which is equals to the e over minus 2t plus c1, because this is the sum constant, right? We can turn it to another constant. We can define it, okay? And so this is also equal to e c1 times e this, and so this is also another constant. We can define as the a, and so the minus 2x plus 5 is equal to minus plus, because we have the absolute operator in here on the on the ln u, and so a times e over minus 2, and in the final form the xt must be equal to the 5 plus minus a times over minus 2t divided by 2, okay? And so the a is a constant value. And so how can we determine the values of the a? How we can solve the a value? How we can obtain it? How can we? From the what? Yes, initial value. If we have this term, for example, this is equals to, for example, to the 1, and so we should put the t is equals to the 0, and then we can calculate the a value, okay? This is so simple, right? Right? Everyone understand what I'm saying at this topic? So what's your name again? Alp. Alp, everything is okay? Okay, thank you. So, we have another method. Trial and solution method. Okay? But what is that? We can propose a solution to differential equations. For example, the xt is equals to the what? C plus d e over st. We don't know the s value, d value, and c value in here. But we can say that this could be, or this may be, a solution of the first derivative of the system. We assume that in this case. For example, we have the x dot is equals to what? The minus ax plus b system in here. Okay? And so the x dot plus a times x is equals to the what? To the b. And we propose the what? The xt could be equal to the what? The c plus d e s t. Okay? We consider that. We accept that. This is the answer. But we don't know the c, d, and s parameter in here. And so how we can solve this equation right now? And so we have the first derivative values of these terms in here. And then the x dot plus ax must be equals to the what? If we take the first derivative with respect to the time, this c value is what? Is 0, right? 0. Because it's not dependent of what? The time. And so we have the exponential term in here, d times, and so just remember the rule of the derivation of the what? The t values in here, the s times e s t can be given in here for the what? For the x dot value. Plus a times, what's the values of the x? Alp? Just say it. Yes. C plus d e over s times t must be equal to the what? The t value. Like b values. Okay? So, if we collect the whole equation in here, just like this one, ds, and so we can reorganize the equation s plus a times d times e over st plus a times c must be equal to the what? The b. Right? This is our equation. Right? And so we can say that this is the exponential term. And so it must be a 0 value. Because we have the constant value and then we have also have a constant value in here. And so in order to what? Equalize this term into the what? Into the 0, s must be equal to the minus a. Right? Because we cannot assign d is equal 0. Because it cannot be. Otherwise, our equation is turning to another one. Right? And so the s must be equal to what? Minus a. Right? And so what about the c value in here? This c value must be equal to the b. Right? A times c. And so we can write that the c is equal to the b divided by a. Right? Do you understand how we can analyze and solve this equation in here? We propose the what? The sum form and take derivative with the basis of the time, and so we cannot assign the d is equal to the 0 because otherwise our equation turns to the what? The constant value, which is not the case. And so s plus a must be equal to the 0, and also a times c must be equal to the b. Right? And so we can solve this equation based on these parameters. Okay? And then we can write the xt right now. The c is equals to the what, Alp? C must be rewritten with the system parameters. Yes, b divided by a plus, what's the d value? We don't know, right? But e over, what's the s? Minus a times d. Okay? Our formula is built with the what? With these nominations, based on these properties. But we don't still yet the what the d value. How can we solve the d value? Still don't know anything about the d. How we can solve it? We can assign the x 0. This is the initial condition because it's the first derivative system. And so if we want to solve this, and so we need to know what the initial condition of the x, right? And so x0 can be given by with the what? With the b divided by a plus d times e minus a 0, right? And so what's the values of these terms? B divided by a plus d, right? And so what's the values of the d? D is equal to the x0 minus b divided by a. Okay? And so if we put the d value in here, just like this one, the final equation xt is equal to the b divided by a plus x0 minus b divided by a times e over at, right? This is our solution for the trident solution methods. Okay?
Huh. Is the equation which we had assumed is random, or
it's not a random. If we are trying to solve the first order equation, and so we should assign the exponential s over t. For example, if we assign any other solution in here, for example, sinus and cosinus should be given in here, and so we need to propose the two exponential term. Or if we have the repeated roots, just like the differential equation, we need to propose the exponential over st plus t times exponential s times t. Okay? This is the first order solution of our system. For example, if we are utilizing the second order example or the solution, and so we need to give at least two exponential terms at a random way. For example, we should define the xt in here, a1 times e minus s1t plus b1 times e minus s2t. For the second order systems. Okay? Get it? Okay. So let's take a break for 15 minutes, and after that we will start to do the Laplace transform method. Okay? Especially for the system dynamics methods.